Hey guys, got you here on Geospace again. That's that University of Michigan product that takes all the data from the GOES 13, 14, and 15 satellites that go around that geosynchronous orbit around the Earth at 22,236 miles. The reason I'm showing you this is the pressure, and look how light it is. Now, it's been light like that before, but as you may have noticed, it got real light there. We had sort of another splash, but maybe not a sploosh event showing up on the Geospace at around today 0102 1045 UTC. There it is there. So take 5 hours off, that'd be like 5:45 a.m. Here it is showing up on the density. It's running through it. Gives you like the last almost 4 hours usually on this simulation. You can see it's about to go through. You'll see it bigger there. There it is. You can see the bow shock was already out pretty far, around 18 maybe. And then when the splish splash hit, it maybe went out to 25 or a little bit higher. As you can see, it's not a huge density wave or anything. I mean, it's a good wave, but it's not high in density, or these colors would be brighter or darker. Now I'll show it to you on the velocity. And these are just the cut planes like I'm going to be showing you on ISWA here in a second. There's the Y cut looking straight across, equatorial plane. It's like a MRI slice through the magnetosphere, magnetopause. There it is, splish, splash, splish. And then there's the Z cut looking straight down on the planet. The only thing different is they got the sun flip-flopped on this one, whereas it would be on the right side on ISWA. And we get a little bit of a different view of computer simulated magnetosphere. Now here it is here. These are the Fock radiation belts. I got them two synced. They're running together basically. Here is the event on ISWA. It's got to be something to do with that big planet out front, I believe. See all those extra magnetic field lines? It's best to click this box down here on the right if you really want to see this stuff well. Those blue lines, they're interplanetary magnetic field lines, and they're only supposed to be associated with, well, mostly solar bodies, which indicate a connection between the solar body and a planet. But planets also have magnetic fields, so they have magnetic field lines as well. Apparently that big planet that crossed ACE, have to read my hypothesis number 1, and I put these below all the videos in the comment section. Pretty much sums up what's been going on, because for any new viewers who haven't been following me, it might be hard to figure out what the heck I'm talking about. So definitely read this hypothesis number 1. And this is about high solar wind speed, but which we haven't been having from Nemesis. That's hypothesis number 2. Now these numbers here, they're all being measured by these GOES 13 and 14 and 15 satellites that roll around here at the 22,236 mile mark. So that was one epiphany that I had a while back, that these solar wind speed numbers are all within our magnetosphere, and they've gone up as high as 1701. you can see right now, they're pretty calm, as are the ones coming from our sun. Gets up to 556. There's one at 600, 652. That was a little while back. 600, 7 something, 781. So it looks like the wind speeds within the magnetosphere are coming down, the magnetopause, and I think that's what's contributing to that lack of pressure and how it's all looking so amorphous. Remember the other day I showed you it was a pretty hostile environment, but it was stable because all the solar wind speeds coming from Nemesis were in the 500 to 600 range, and the ones coming from the sun to the earth were in the 500-600 range, and this was all angry orange and red colors, but it was still pretty well balanced. So, but now it's well balanced, but the numbers are all coming down, and that can be reflected there, I think, in that lack of pressure. And since the solar wind speed coming from Nemesis basically usually always runs higher than what's coming from our sun, that's what's pushing the bow shock out, in my humble opinion. Now here's ACE the last 3 days. You can see the solar wind speeds coming down. Was it 500 plus, maybe 525 around there on right around midnight, New Year's Eve, and then it's steadily declining ever since. Now it's down to a little above 300. So that's the last 3 days. You can see by this phi angle, the 180, you can see it's been fluctuating quite a bit, but always tending more toward the Earth to Sun connection or Sun to Earth connection at 180, Earth to Sun at 0. Now it's kind of rolled up into, from about noon yesterday, it's rolled up into a straight, pretty stable 180, which indicates a Sun to Earth connection. You can see it here. That's as stable as I've seen it, so that's another reason why I believe this environment's looking so amorphous and so stable. And there you can see the wind speed's down about 350 there. Now on Discover, this is the last 7 days. You can see the same thing here. We got a couple of big gaps. These gaps are data gaps. So I got you on the Discover ground tracking station schedule. You can see the one yesterday was from 22:59 UTC to 7:20 UTC. So that's 8 hours. Wow, 8 hours and 21 minutes. So that gap got bigger. Over here it was from 12:31, 22:10 UTC to New Year's Day, 5:34 UTC. So that would be an hour and 50 plus 5:34. So that's 7:24. So this gap's actually getting bigger. So whatever it is, it's gapping out and keeping the Discover satellite from relaying its data to the Earth. I would say is getting closer to the planet, probably our planet. And maybe it's this culprit here. Here's yesterday's MLSO run. Got quite a few frames. These frames are running, looks like about a 2-minute time lapse, a little bit less. See, 23:49:52, 23:51:38. So it's 14 seconds shy of 2 minutes on the time lapse. I'll leave it play at real speed so you can see. And I think if you go back and look at some earlier vids, these objects were always here, but they weren't this large. Now look how big they are. And they're moving. You didn't see them moving before. So that also would indicate to me the fact that, of course, they're larger would mean they're closer, and the fact that we can see them moving would indicate more closer proximity, I would have to surmise, to the planet. And one of them's blocking the data from ACE. Now here's that phi angle thing I was telling you about. Here's Solar Ham space weather tutorial. I put that link under my videos in the description box. So real quick, this is what I'm talking about when I show you that blue phi angle. If it's 0, that means the interplanetary magnetic field connection is from the Earth to the Sun. If it's 180, it's from the, Sun to the Earth. Here is the L1 Lagrange point. This is where the ACE satellite and the Discover satellite reside. There's like a little saddle up here. So I mean, it's still a pretty big area, maybe. Well, it's big area. They go around in here with relative ease without having to expend much fuel at 930,000 miles in front of the Earth. This is in order to gather solar wind data and act as also an early warning system to power down some of these satellites or whatever whenever we get a CME approaching. So that's why you see maybe you see a gap on Discover and not one on ACE, because they're in the same relative vicinity, but they're not like right next to each other holding hands. So we're in a relatively calm period right now. I'm very calm, as a matter of fact, because everything's like the same. Solar wind speed from Nemesis and the Sun are relatively similar, and the connection's stable. It's not fluctuating up and down, and I think you can see this reflected also in the last 24 hours. Earthquake showing up on Earthquake 3D. There's the last 24 hours. That's pretty light. I mean, that's as light as I've seen it that I can ever remember, to be honest with you. And I'm not trying to be dramatic. Got no deep quakes out here like we usually do. Go back 2 days. This is about when the stable connection got established with the Sun at the 180 mark. We still got a few deep quakes showing up there. But anyway, I just wanted to point that out real quick. So with that newly established stable connection between the Sun to the Earth, through the big planet and through Nemesis, because I still believe they're all four connected together, and maybe that's why things are becoming more average, like they're equaling each other out a little bit, because they're all connected magnetically speaking, interplanetary magnetically speaking. And right now the connection's pretty stable, and being that everything coming from the Sun's pretty weak, we're getting some weak solar, we're getting some weak wet space weather around the planet, at least according to these simulations. I mean, still the bow shock's pressed way out. Normally it's supposed to be a 10. So I think the solar wind speed being elevated somewhat higher than what's coming from the Sun's pushing the bow shock out. We're still getting all this pressure here. So I got these two synced, they're running together. I got these two synced, they're running together. I'm going to slide this one through for you. Another thing I wanted to make mention of, used to be this blue plasma would get ejected. Now it's really hanging around, and you can see it reflected here. That's all plasma, high energy stuff. And then look at the blue field lines. This is from that big planet in front. And this is right around the time when we had that Splish Splash event on Geospace. 10:45 UTC. You can see it coming through that wave right around the same time. And look at the blue field lines. Oh well, running out of time. God bless, peace, and I'm out.